In today's lesson, we'll be learning about the sine law. Here is the sine law expressed in two different ways. However, they both mean the exact same thing, and you are going to get the same answer whether you use the formula at the top or the formula at the bottom. Now, the sine law is used for non-right angle triangles, so acute triangles. If you have a right angle triangle, it would be better to use the Pythagorean theorem or SOHCAHTOA. The lowercase letters represent the side lengths. Meanwhile, the uppercase letters represent the angles. Now you'll notice that the sine law uses the letters A, B, C in both lowercase and uppercase. However, you can change the sine law to any variables you wish. It could be X, Y, Z, D, E, F. It completely is up to you, or it depends on the question and the diagram that is provided. In our first example, we want to find the length of the indicated side in each triangle to the nearest unit. The first thing you want to do is create a diagram if a diagram hasn't been already provided. Once you've created a diagram, you want to label it. As you can see, each angle is labeled uppercase A, B, and C, while the side length is lowercase a. This would be lowercase c, and this would be lowercase b. If possible, it would be a good idea to try and solve each of the angles within this triangle. Now, you know that the interior angles of a triangle adds up to 180 degrees. Therefore, if I wanted to find angle A, I would just take 180 degrees and subtract 53 and subtract 71, which would give me approximately, or not approximately, exactly 56 degrees. At this point, I'm going to label angle A 56 degrees. That might become handy later on. Once you've completed your diagram, let's rewrite our formula. So I have side length of A over sine of angle A, side length of B over sine of angle B, and I have side length of C over the sine of angle C. You want to substitute in your known values. Since I am looking for the value of A, that's going to stay exactly the same. I've just figured out angle A, which is 56 degrees. Side length of B is 4 centimeters. Angle B is 71 degrees. The side length of C is unknown, while the angle C is 53 degrees. Now, you want to look back at the question and see what you're looking for. We want to find the length of the indicated side. The indicated side is A. So we're going to be working with A over sine of 56 degrees because we want to solve for A. However, I have two other fractions that I could be using, but you want to be using the fraction which has numbers both in the numerator and denominator. So I'm going to be using 4 over sine of 71 degrees. So let's go ahead and rewrite those two fractions. So A over sine of 56 degrees is equal to 4 over sine of 71 degrees. You want to use your cross multiplication at this point. So I have A multiplied by sine of 71 degrees, and I have 4 multiplied by sine of 56 degrees. Keep in mind, you want to isolate the variable of A, but A is stuck with this sine of 71 degrees. You'll notice that the operation in between these is multiplication. So the opposite of multiplication is division. And you want to divide both sides by the sine of 71 degrees. Those cancel out, which just leaves you with A is equal to 4 times the sine of 56 degrees divided by the sine of 71 degrees. Now, you can always enter this one at a time, but I'm going to enter it all at once into my calculator. This is approximately equal to 3.5 1. And since the question specifies that it wants it rounded to the nearest unit, this would just be about 4 centimeters. Therefore, using the sine law, we've just discovered the side length of A to be 4 centimeters. In our second example, you want to find the measure of the indicated angle in each triangle to the nearest degree. The first thing you want to do is create a diagram if it hasn't been already provided. If it has been provided, you can complete its labeling. So this would be lowercase y, this would be lowercase z, and this would be lowercase x. Now, in terms of the angles, we've only been given one angle, so we cannot figure out the other two angles. And we've only been given 2 of the side lengths, and since it's not a right angle triangle, we cannot figure out the third side length. Which means we're going to have to use the sine law. So, like I said earlier, the sine law is not restricted to the variables of a, b, c. You can use any variables that you wish. So, I'm going to be using lowercase x, the sine of angle x, lowercase y, the sine of angle y, and lowercase z, and the sine of angle z. At this point, you just need to substitute in your known values. So the side length of x is 17 millimeters, angle x is 65 degrees, side length of y is 13 millimeters. The angle of y is unknown, so you're going to leave it as capital Y. And in terms of z, we do not know the side length or the angle of z. Now, if you look back at the original question, we need to find the measure of the indicated angle, and the indicated angle is angle y. So we are going to be using this fraction for sure. Now we need one other fraction, and I have 2 choices. You're going to be using the fraction which has both its denominator and numerator filled with numbers and not variables. Okay, so at this point, we are going to rewrite those 2 fractions, which are equal to another. You want to use cross multiplication, so I'm going to have 17 multiplied by the sine of angle y equals 13 multiplied by the sine of angle 65 degrees. Now, at this point, you can try to simplify some of these numbers. I'm actually going to simplify everything at the very end, but you can change it to decimals if you want right now. We want to isolate angle y, but angle y is stuck with a multiply by 17 and is stuck with sine. So let's get rid of the multiply by 17 first. And the opposite of multiply by 17 is divide by 17. So I'm going to do that to both sides. So those 17s cancel out, which just leaves me sine of angle y and 13 multiplied by the sine of 65 degrees over 17. Now, you could take 13 multiplied by sine of 65 degrees and divided by 17 and write an answer here. However, like I mentioned before, I am not going to simplify it into the very end. Since we're looking for an angle, you need to do the sine inverse to both sides. So that would be the sine inverse of 13 multiplied by the sine of 65 degrees divided by 17. Now, if you punch this into your calculator correctly, you should get approximately 43.87 degrees. However, we need to express this answer to the nearest unit, which would be 44 degrees. Therefore, angle y is 44 degrees.